I can actually write on it. This one, oh, look, it is glittery. 1 and 5. And do the rest. Serious? Okay. We did a couple of these together. I can't remember which ones, but we'll look. All right, domain is left, and I told you don't worry about the function part. All right, left to right. So the furthest left I go here is what? -5. Is it a bracket or a parenthesis? And then it keeps going until I get here, which is +5 bracket or parentheses. Range, bottom up. So the lowest it ever goes is what? -2. Now here's the kind of confusing part, because at -2 here, there's an open dot, right? But it actually is defined at 2 here, so I'm going to do a bracket. Because somewhere y can be 2. And now as I go up, what's the highest it goes? 2. And that is a bracket. How about domain on number 3? Left to right. That's right. -infinity to infinity. Left to right, there's nothing that's stopping it. How about from the bottom up? -infinity to infinity again. Anybody confused? Number 4. Domain, left to right. -infinity to infinity. That's it. How about the range? Just 3. The only thing y can be is 3. I would just put just a singular 3 in brackets, or just put y equals 3 or something like that. It doesn't matter. That's not so. Yep. You didn't have to do 5. How about 6? What's the domain there? -infinity, because it goes left forever and ever and ever. So -infinity, and then it stops at 4. Bracket or parenthesis there? Bracket. What about the range from the bottom up? That's the domain. That's the x part, but what's the lowest on y it goes? 0. That's right. 0, and it's a bracket because that point is filled in, and then it goes up forever. Backwards. Make sure you do smallest first. Oh, I see what you're saying. How about the circle? What's the domain there? Smallest x ever gets is -2. The biggest it ever gets is +2. That is included because those points are actually there. How about the range? 1 to 5. That's exactly right. They aren't supposed to be using that door. Huh? No. How about number 8? What's the domain? -infinity to infinity. How about the range? 0 to infinity. How about the domain on number 9? Left, the furthest left it goes, or the smallest x it ever takes on. -4, it looks like, yeah. That's going to be a bracket up to what? 3. And then the range from the bottom up. To 5. Brackets or parentheses? Parentheses on both of them is correct. Yep. Yeah. Part credit. How about 10? Domain. -infinity to infinity. How about the range? That's right, -3 up to infinity. I need a parenthesis on the infinity because I always need parentheses on infinities, but that -3 gets a bracket because of the... How about 11? 11's a little tricky. Domain. All right, let's look left to right. Yes, I agree. You start at -4, and it's a parenthesis. But something happens. Look at this and this. It can't be those points. Remember how we leave out just one value? Y'all remember that? That means I go from -4. I keep going, but I hit a roadblock at -2. And I can't actually be -2. But I can get real close to it. And then I can get real close to the other side of -2 and keep going until I hit +2. And same thing there. Remember, back-to-back parentheses like this leaves out just that number. So that's the answer, all those parts there. Yeah. Possibly. How about the range? All right. I heard negative infinity and I heard -4. Why is it negative infinity and not -4? Because I see this stopping right here at -4. This end over here is going down forever. So at some point there is graph there. So I got negative infinity, and then I go up until I hit 1. Does the 1 need a bracket or a parenthesis? Bracket. Why a bracket? Even though these are open on this end, it's a line there. That's exactly right. And so at some point, y can be 1. That was a tough one. How about 12? What's the domain? -3 to 3. Inclusive or exclusive? Inclusive. How about the range? Inclusive, exclusive? What are you laughing at? I bet he does. What does inclusive? Yeah. He was answering it right. Let me just show you while we're here too on this page, since we're not taking our quiz today. This won't be on your quiz, and we'll do a section, a unit on functionality. But this is something that you should have learned in Algebra 1. I'm not going to assume you did. Let's do a different color. Do a darker. All these keep asking you about, is it a function, is it a function, is it a function? What does it mean to be a function? Anybody remember? That's exactly right. If you can, it's called, we use the vertical line test. So every single x can have one and only one y. We also talked about this very briefly when we did that Kahoot on the first day. If you can take a vertical line anywhere on there, a lot of times teachers tell you it's the pencil test. You take your pencil just like this and go across the graph. If it ever touches more than one, not a function. So all of these, let's see, let me show you one that's not. It's easier to show you one that's not and then go back. This circle, if I were to drop a vertical line right here, see how it crosses twice? That means it's not a function. It can only hit one time no matter where you put it. If I come over here and I look at, this is actually a quartic, and we'll talk about that later. There's no place that I could draw a vertical line where it would ever intersect the graph more than once. So that means, yes, this is a function. Is number 9 a function? What do you think, Rhett? Is it a function? Why? It'll hit twice. That's exactly right. And it'll actually hit a bunch of times there if you go through right. So if it hits more than once, it's not a function. Again, we'll talk about this a little more in detail a little bit later on. How about number 2? Is that a function? Yep. There's nowhere I could drop a line to hit more than once. How about 3? Yep. How about 4? Yep, still a function. How about 6? We said 7, we said 8, we said 9. How about 10? 11? Can't tell what it is. It did this. Yes. How about 12? Does that make sense? All right. Y'all need a stretch break or anything before we jump into the good stuff? Yeah? All right. And ready to go now because this is very, 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 very important. Fundamental in Algebra 2, I would say it is factoring. From the time we use it until the time you finish AP Calculus, it is still a fundamental concept that we use over and over. So if you learned it before, that's awesome. I may teach you in a different way than what your previous teacher taught. I mean, it's technically an Algebra 1 standard. I'm going to teach you as if you've never seen it before, though, because it's that important. So there's a sheet coming around to you. We're not going to reference it just yet. I just wanted you to have it for whenever we do get to it. If you don't get this the very first time I show it to you, it is okay. We will practice with this so much you won't have any choice but to learn it. So a couple things before we start actually factoring quadratics is I want to talk to you about a GCF. What does GCF mean? Greatest common factor. Tell me if you were explaining that to someone who had never seen it before, what you would tell them that means. Okay, so how would you advise them to find it? If I gave two numbers, let's say I gave you 25 and 70, and I said, what's the GCF? What are you looking for there? Not multiply, but you're right. So looking at these, I'm looking for the biggest that I can divide because factor and divide go hand in hand. I'm looking for the biggest thing that I can divide them both by evenly with no remainder. In other words, if I looked at 25 and I listed out all the things that I can divide 25 by. Well, 1, and let's go in order. Let's go up. I can't do 2. I can't do 3. Can't do 4. I can divide it by 5, right? Are there any other factors of 25? 25 itself, right? Now let's do the same for 70. What are the factors of 70? 1, 7. Oh, we forgot 1. 2, 5, 7, 10, 35. 14 go in? Oh, 14 and 5. 14, 35, and 7. Okay, so out of those listings of numbers, what is the one that they share, the biggest one that they share, and that's my GCF. So the GCF would be 5. Now, because this is algebra, we're going to throw some variables in there. So what if I said I have 25x squared and I have 70x? What would you tell me is the greatest common factor? 5 what? 5x, because with variables, I want to take away the most that I can from both of them. This one has 2 x's, this one has 1, right? So the GCF there would be 5x. Does everybody understand the concept of GCF? I know that goes way back to prior to Algebra 1, but I just want to make sure. That's the key to factoring, is being able to find a GCF. Everybody okay? All right. Let me then show you. Here's what we're going to do. Again, still not factoring. Let me just make this X, but we'll start out. If I told you to multiply that out, tell me what you'd do. I would do that FOIL thing. That's exactly right. So I'd start with the first, I like to call it distribute because that's really what we're doing. We take everything in the first parentheses and distribute it to everything in the second parentheses. So I start with the x and I distribute. So x times x is close, x squared, right? X times negative 3, negative 3x. I'm done with that first one because it's already distributed to everything in that second parenthesis. So now I move on to the next one. 2 times x, 2x, and 2 times negative 3 minus 6, okay? I know this is probably, going back, most of you already know how to do this, but I'm driving a point home here, and you'll see it in just a minute. Now what do? Combine like terms, simplify, right? Add them together. What goes together? Only the like terms. Which ones are like terms? That's right. Same variable, same exponents on them. So negative 3x and 2x. So I end up with x squared minus x minus 6. Now, to go from here to here, I multiply, right? But what we're going to do is we're going to go from here to here, and to do that, we factor. The way that I am going to show you to factor does these exact same steps in the reverse order. There's no guessing. A lot of teachers teach you with a guess and check method. I hate the guess and check method. But there's a variety of ways you can learn to factor. If you do it the way I show you, it will always, always, always work for every quadratic, and it will it goes in the reverse order of the FOIL. All right. How many of you already know how to factor? Anybody? Okay. All right. Well, nothing to it but to do it. I've got you some steps on here on this page, okay? It runs through. There's an example at the top. The steps are printed out for you so that you don't have to, if you want to write them as we go, you're welcome to. Or if you want to follow along on here, and we'll do the example together, however, whatever's easiest for you, and then there's several on the back for us to do together. But this is just something students have always struggled with factoring, so I made a little handout a few years ago to kind of try to help you. All right, here we go. Remember, we're starting with something like this, and we're ending in factored form, which, by the way, if we're talking about graphing, this looks like standard form of a quadratic, and this looks like what? Intercept form. So essentially what we're doing is we're going from standard form to intercept form, which is factored form. Okay? All right. We've got an example here, 12x squared plus 14x plus 4. The very first thing we're going to do in this process is we are going to look for a GCF that is shared by every single piece. Do you see a GCF in this? Okay, now they all won't have one. If they don't, you skip this step. But if they do, it's very important that you recognize it because we got to take it out. 2. This has a GCF of 2, right? I can divide everything by 2 and have nothing left. So that's exactly what I'm going to do. Remember, factor and divide are kind of the same thing. So what I'm going to do is I'm going to take that GCF of 2 out. And to do that, I'm going to put it outside. I'm going to backwards distribute. Remember, this is the backwards of the FOILing. This is the backwards of all that. So instead of distributing and multiplying, I'm taking it out and dividing. Okay? So what's left when I divide by 2? Plus 7x plus, all right, is anybody confused taking out a GCF? Everybody's okay. All right. Now here's what we're going to do. We're just going to focus on this part in parentheses. We're going to ignore the 2 outside. It's going to follow our problem down, but it's not going to do anything for us. We're just going to leave it alone, okay? So for right now, I'm just focusing on this part. Now here's what I want to do. Take the first And the last, and this is important in standard form, notice, okay? We always want to be in standard form. Take the first and the last two things and multiply them together. What do you get? 12x squared. Now, here's the puzzle. I need two things that multiply to 12x squared, but they have to add up to 7x. So when I multiply them together, I get 12x squared, but when I add them, I get 7x. 4 and 3, right? 4x and 3x. Now, I've told students before, if you can't find it, start listing all the factors. What all multiplies to 12x squared? 1x and 12x. 2x and 6x. Anything else? 3 and 4 that I have. So now all these satisfy the multiply, but of those, which ones add up to what's in the middle? 4 and 3. Okay? So now what I'm going to do is I'm going to take this middle. Remember that 2 is just, I'm just going to absolutely ignore it. And in these parentheses, what I'm going to do is instead of 7x here, I'm going to change it to 4x plus 3x. Does that still equal 7x? It sure does. I just split it up into these two pieces. That's all I did. I rewrote it. All right, here comes the fun part. It's all easy peasy once you get here. I call this the slash part. Go to the middle of the problem after the first two. Remember, I'm only looking at what's in blue. I'm just ignoring that green 2, and I'm going to ignore it all the way down. I'm never going to do anything else with it. I'm going to slash it. And I'm going to look at this as two separate problems. Problem 1 and problem 2. For each of those two problems, I am going to take out a GCF. Even if I don't think it has a GCF, everything has a GCF of 1, right? I can divide everything by 1 with no remainder. All right, so let's look. That aggravating green 2 is still there. What's that? So now look at the 6x squared and the 4x. GCF of those two. 2x, right? Because they both have an x on them. If I take 2x out of here, what is left? 3x plus 2, right? Because I'm taking it out of both of these. Anybody confused? Middle sign stays. It always stays. Now I look at these last two. What's the GCF of 3x and 2? 1. What's left? Everybody okay? Again, that obnoxious green 2 is still out there. I'm just going to ignore it. Do you notice how these two parentheses are exactly the same? If you found the right factors, if you slashed correctly, they will be exactly the same. Okay? Bless you. Write them one time. And then write what's left. So if I take those off, what's left? 2x plus 1. Bless you. Now I am completely factored. And what's cool about it, if you look back at this other one that we did, you see how we started out with two parentheses and see how it's split up in the middle like this? We've got it split up in the middle here the exact same way we just went backwards. What do you think about factoring so far? All right, let's practice with it. There's a couple of tips on the bottom that I've seen where students mess up. So be very careful. It says the first one, be systematic. List your factors from smallest to largest whenever you put it in. I did not do that here, but it's okay. But I always say list them all out if you can't figure it out. Make sure if you factor that GCF out in step 1 that it follows the problem down. Don't ever drop it. It just keeps on showing up, right? It's very obnoxious. Even got in here, it's like that annoying third wheel. It's always there. It just keeps falling down, right? We'll talk about C positive versus C negative in just a minute. C positive. And you can always check your work by foiling your answer out. Okay, if you multiply it, FOIL it back through, you should end up back where you started. All right, so let's do these together on the back. Here we go, number 1. X squared plus 6x plus 5. Tell me the first step. GCF. Does this one have a GCF? 1, right? I'm not going to pull out a 1 on these in the first step if it has it. That won't be the case whenever I'm factoring before, but in the beginning, if it's anything other than 1, you'll want to take it out. But here, since it's 1, I'm going to go on. So that's nice. I don't have that aggravating piece to keep following my problem down on this one, right? Tell me what to do now. What's step 2? Multiply the two ends together, right? X squared times 5 gives me 5x squared. I still, even now, write this off to the side as long as I've been doing this. What multiplies to 5x squared but adds to 6x? 1 and 5. 1x and 5x, right? If I multiply that together, I get 5, yes? But if I put a plus sign in here, I end up with 6. Does that make sense? No? Kind of? Okay. You multiplied to this and added to that. Multiplied and added to, yeah. All right, everybody okay? All right, once you get that part, the rest is fairly easy. That's the hardest part, is finding those two numbers. All right, so I've got x squared, and I'm just going to rewrite this, plus x plus 5x plus 6. Slash it into two problems. The middle sign always stays with the last ones. What can I take out of those two? 1x. What's left when I take that out? X plus, what if I take everything away? 1. Because it's really a division problem. So what's x divided by x? And that's 1. All right, how about the second 2? What can I take out of that? 1. Somebody said 1. Right? Because there's not a GCF. There's nothing that I can divide 5 and 6 by without a remainder. So it's 1. What's left when I do that? What'd I do? Oh, man, yes. Y'all didn't even slut. Yes. Great day. Nobody even told me I wrote it wrong. All right, what's the GCF now? 5. And it leaves me with, did everybody see how I knew I went wrong right there, though? If you get down and your parentheses don't match, something's gone wrong. You've made a careless mistake somewhere, or you picked the wrong factors. And so I knew right away something went wrong, which is a clue. Go back and look and see where it messed up. And then I quickly saw that, look, I had written this as a 6 instead of a 5. The only thing you are rewriting is this middle one, and it's changing into these. Y'all okay? All right, once the parentheses are the same, I just take them out, write them one time, and what's the second factor? X plus 5. I know this is a lot with me working through with you, but there's different scenarios that happen as the signs change. That's why I got these specific 4 ones on here that I want to work through with you, and then I'll give you some time to practice. Look at number 2. And y'all got to stop me if I'm going too fast or you don't understand. X squared minus 4x minus 12. GCF. 1. So do I need to take it out in the beginning? No. Go on to step 2. This is where it starts getting a little bit trickier, right? Because look what happens when I multiply the first and the last together. What do you get? Negative 12. Now, what's the only way to get a negative number when you multiply two things together? A positive and a negative. So as I look at this, and I'm looking at my two factors, one of them needs to be negative and one of them needs to be positive. Because they got to multiply to negative 12, right? So what two numbers multiply to negative 12, but add to negative 4? Negative 6 and 2. Does everybody agree? All right. I'm going to rewrite that middle. What now? Split it in half. Slash it. What's the GCF of the first two? 1 what? X. What's left? You take an X out of those first two, what's left? X minus 6. The middle sign stays. What can you take out of the last two? A 2, and what's left? What goes in the front? X minus 6. What's the last factor? Students always ask, does it matter the order that you put these in? No, it does not. You could have flipped these up and had them in a different order. The only thing that's going to make your problem do is at the end, you would have ended up with x plus 2 times x minus 6. But it's exactly the same thing because multiplication is commutative, right? I can do it in any order I want to. I know I'm boring y'all to death. Some of y'all came with your eyes open. Am I boring you? Or are you just sleepy? You ate that big old sandwich and now you're falling asleep. All right. Yes. I factored a 2 out. I divided both of them by 12 and by 2 and I got x and 6. Any other questions? Kick it up. We always kick it up a notch in here. Tell me why this one looks funny. There's no b. If there's no b, what is b? A 0. Remember I told you this method will always, always, always work? This method always works. I can still factor with grouping. Do I have a GCF? 4. Absolutely. If I take out 4, what's left? X squared minus 9. I'm going to keep the 0 in here just so I can see, because here's what happens. I've got to multiply these two together, right? Again, they multiply to a negative number. When they multiply to a negative, that means one of the factors needs to be negative and one needs to be positive. But what do these two add to? 0. There you go. Negative 3 and 3. A good rule of thumb. And again, it doesn't, that's why I love this method, is it doesn't, there are no solid rules that you have to do this every time. But if you write that negative first, when you go to factor, it's going to make your life a lot easier. You don't have to. It'll still work if you don't. And I'll show you what happens on the next one if you don't. But for here, I'm going to write this as x squared minus 3x plus 3x minus 9. And look, if I combine like terms, I'm back where I started, right? All right, what now? Split it, slash it. 4 times, what's the GCF for the first two? 1x, what's left? There you go. The middle sign stays, What can I take out of the last two? What's left? That 4 is super Aggie, and he stays with the problem all the way down. Take out the common factor here, and what's left? How are you feeling so far? Good. Let me kick it up just a little bit more then. Last example, and then I'll let you practice some. That's exactly right. This one does have a GCF. Again, most of yours will not have a GCF. I threw some ones on here that I knew would kind of be tricky for you. And so that's why a lot of these have GCFs. But there is a GCF of 2 here. And what's left when you take that out? Uh-huh. All right. This time, I'm multiplying to a positive number, but what do I have to add to? A negative. What does that mean? Both of my factors here need to be negative, right? So what multiplies to positive 6 but adds to negative 7? Negative 1 and negative 6. So I've got negative 1x and negative 6x. Is anybody confused about where those two came from? All right, I'm going to rewrite my problem. X squared minus x minus 6x plus 6. Again, slash it. What can you take out of the first two? X, 1x, what's left? X minus 1. Now here's where you need to put a big note in your notes, or star it, or highlight it, or whatever you do. This middle sign stays, yes? But here's what's happening. Because it's negative, anytime this middle sign is negative, here, it changes the last sign when you factor. And the reason for that is because really, I'm not factoring 6 out of this. I'm really factoring negative 6 out of this because of this minus sign, which means it leaves me with x minus 1 instead of x plus 1. Because remember, I told you if your factors here don't match exactly, you've done something wrong. So when the middle sign is minus, it changes that last sign. Now I have 2 times x minus 1, and what's left here is x minus 6. Tell me what you think. It's every possible scenario I can think that you'll encounter at least today. No, factoring will not be. Normally it would be, but really you should have it today, and you didn't, so it will not be on the quiz tomorrow. Graphic.